So this is my ionic model of calcium chloride. We have 1 atom of calcium and 2 atoms of chlorine. I have 2 big marshmallows labeled Cl, which means chloride, or chlorine, I guess. And then Ca, which represents calcium, and then together these all form calcium chloride. The small marshmallows represent valence electrons, and calcium has 2 valence electrons, and each atom of chlorine has 7 valence electrons. So calcium here is the cation, and this is basically because calcium has these 2 extra electrons that it wants to give away, and then the chlorine atoms are anions because they actually need an extra electron, like see the empty toothpick. Calcium has these 2 extra electrons, and chlorine needs, each atom of chlorine needs another one. Like, how convenient is that? So all chlorine has to do is calcium will give chlorine its electron, and then this other chlorine will take an electron from calcium, and now each atom of chlorine has a full octet of 8 valence electrons, and calcium's happy because it gave away both its extra electrons. So since these metals each got 1 electron from calcium, they're like fine now, they're happy, they got their full octet, whatever. So that's basically why the ionic bond works out. So one limitation I would say about my model is that since I use the toothpicks to connect the valence electrons to the atoms, in real life obviously bonds are invisible, so you can't see bonds and they're not really visible at all. So that's one limitation of my model. The limitation of my model is pretty obvious. Like, you can't see atoms and electrons and stuff like that, and they're obviously not marshmallows, but I mean, it's just a model, so